We learnt about the Coulomb force between the two charges Q1 and Q2. After that, already we discussed the electric field due to a charge Q at distance r is E equal to 1 by 4 pi epsilon naught q by r square unit vector r, and also if a test charge is placed at distance r, then E equal to q into force experienced by this charge. Now we should recap the principle of superposition once again in terms of electric field. Electric field at any point in the space due to a number of charges is the vector sum of all the fields on that point due to the charges taken one at a time. So today our purpose is to find the electric field due to a system of charges. Let us consider n charges Q1, Q2, Q3, Q4 and so on located at points with position vector R1, R2 and so on relative to some origin O. We may take that origin somewhere. And point P with position vector R from the origin. Here we have to find the electric field. First, by using the Coulomb's law and definition of electric force, we can say electric field E1 due to the charge Q1 at distance R1 is 1 by 4 pi epsilon naught Q1 by R1P square unit vector R1P, where R1P is the unit vector in the direction from Q1 to this point P, and R1P is the distance between this Q1 and the point P. Similarly, E2 equal to 1 by 4 pi epsilon naught Q2 square Q2 by R2P square unit vector R2P. Now, if we use the superposition principle, the net electric field E at R due to the system of charges will be summation of all these electric fields. Here, see this, we will get this equation. Further, if we substitute the value of E1, E2 and En, we will get this form, that is Er equal to 1 by 4 pi epsilon naught Q1 R1P square unit vector R1P plus so on, that is equal to 1 by 4 pi epsilon naught summation I equal to 1 to n Qi by Rip square unit vector Rip. In terms of vector, as we discussed in the principle of superposition, we will get this equation 2, and in terms of position vector, we will get this equation 3. So try to get equation 2 and equation 3 at your own. Remember, here R is the position vector of point P where electric field is to be calculated relative to origin O. Now, three questions here given. 2-point charges plus minus 3 microcoulomb are located at points A and B 20 centimeter apart in vacuum. What is the electric field at the midpoint of the line joining the two charges? And if a negative charge of magnitude 1.5 into 10 to the power minus 19 coulomb is placed at this point, what is the force experienced by test charge? 2-point charges 4Q and Q are separated by a distance 1 meter in air. What At what point on the line joining the charges is the electric field intensity 0? And third, four charges, each of magnitude q, are placed at the corner of a square of side 10 centimeter. Find the electric field intensity at the center of the square. Thank you.